I want to use what's called Gaussian elimination with back substitution. Now, for now, our goal here is going to be to get a triangle of zeros in the bottom left corner. So that means down here, I want to use the row operations to get nothing but zeros down here. So let's think about what we could do. We've already got a 0 here and here. So I need to get a 0 in this place. So what I could do is I could say take the third row and subtract half of the top row. And there's nothing wrong with that, but it would give us some fractions. So instead, what I want to do is swap these two rows, and then we'll get a 0 down there in the bottom. So what I'm going to do is I'm going to do row 1, interchange with row 3. So row 2 does not change. You get 1, 0, 2, 5 on top, 2, 4, 1, 16 on bottom. And this notation here where I said row 1 interchange with row 3, I'm going to want you to use this notation when you're doing this with matrices because that's really the only way I can give you partial credit. If you go through and do a bunch of operations and you get the wrong answer, if you don't tell me what you're doing, it can be really difficult for me to figure out what it was. So on tests, I'm going to require you to do this. All right, let's get a 0 here. We'll do that by doing this row minus twice this row. The notation for that is row 3 minus 2 times row 1. When we do that, the first thing is the row that changes. So when I do this next matrix, rows 1 and 2 are going to stay the same. But my third row is going to change. What I'm going to do here is 2 minus 2 is 0. Then I'm going to do 4 minus 4, or I'm sorry, 4 minus 0 is 4. Then 1 minus 4, because remember we're doing the bottom row minus twice the top row. So 1 minus 4 is negative 3. And then 16 minus 10 is 6. All right, so we're looking good, but now we need a 0 here. And what we can do to get a 0 here is do this row minus twice this row. So I'm going to do row 3 minus twice row 2. And again, row 3 is the one that changes. The other two stay the same. And now I'm going to get, let's see, 0 minus twice 0. Tell you what, maybe I should write this out. Row 3 minus twice row 2. So I get 0 minus 2 times 0. Then I get 4 minus 2 times 2. Then I get negative 3 minus 2 times negative 1. Then I get 6 minus 2 times 4. So those numbers give me, let's see, 0. 4 minus 4 is 0. That's negative 3 plus 2 is negative 1. And this is 6 minus 8 is negative 2. All right, and now we're good to go because we've got our triangle of zeros here. All right, once we've got that, we can rewrite this as a system of equations. This bottom one is going to give me, let's see, negative z equals negative 2. This is the back substitution part because we're starting here at the bottom and we're going to work our way back. Negative z equals negative 2, so that gives me z is 2. And then I'm going to come up here to this row. The second row gives me, remember this is x, y, and z. So the second row gives me 2y minus z equals 4. So that gives me 2y is 6. So y is 3. And then we'll go back to the top row. And I'm going to use this equation. I'm going to use this, but I could go back and use the original top. But this says, this right here says x plus 2z equals 5. So that gives me x is 1. Now on this one, I had a 0 in that place. I had a 0 here. If we didn't have a 0 there, then we would have had to substitute in for x and y, but that's okay. I'm sorry, for x and z, but that's okay because we already had y and z. So anyway, that's a Gaussian elimination with back substitution. The reason it's nice is because, once you get this into the sort of triangular form, you can go backwards and solve for the different variables. All right. We have more examples, but we'll pick up on those in the next video.